Welcome to commercial wiring. Before you come to class next week, we have a few symbols that I would like to go over so that we're prepared and ready to begin some calculations on load calculations for a commercial building. There's a few symbols that you'll need to know so that we're able to do that. We'll start with a receptacle. So this symbol right here is the symbol for a duplex receptacle, or this is the same kind of receptacle that you have in your house. It has two plug-ins on a single yoke that fits inside of a single game box. If you notice, there is a little number out to the side of each of these receptacles. And that is telling us which breaker number each of those receptacles go to. We'll see that in more detail in a few moments. Next, we have a quad receptacle. This receptacle is also a GFCI receptacle. We know it's a quad receptacle because it has the two lines like the duplex, and then it has another pair of lines going in the opposite direction, perpendicular, and that tells us this is a quad receptacle. And so what that is two duplex receptacles side by side in a double game box. So a box that's big enough to hold two receptacles. That's what this symbol is showing us. Once again, we have the numbers out to the side telling us which breaker number each of these receptacles go to. Next, we have this circle in the ceiling. These represent lights, and the E out to the side, accompanying these prints. So there should be a table that tells us what the manufacturing information is on these particular lights, and that E would locate us to that particular place in that table so that we know what the parameters are for that light, how many amps, how many volt amps that is drawing. Next is this little S right here, which stands for a switch. Right? If you notice, there is a line going from the switch to each of the lights that it controls. So that's how we know what light is on what circuit. The lines interconnect everything that is on that particular circuit. We also have these long boxes with the little circles. Those are also light fixtures, some type of fluorescent light. It's not specified, but that F, if we follow that F back to the table, it would tell us what the parameters were for these particular lights. The same with this Q for this light. All of these are interconnected to this switch right here. Next, we have this F inside of a box with a little triangle. That's a fire alarm, and that triangle is showing us that it has a horn. And so right here we have one that does not have the horn on it. This would be just a flashing light fire alarm, and it is located near the point of exit to direct us towards the exit in case of a fire. Down in this left-hand corner, we have a circle with a triangle. The circle with a triangle is a symbol for a special purpose outlet. This one happens to have a W/D, so it's going to be for a washer-dryer combo. That's going to go into this corner for this beauty salon. We also have these S's in the octagons. Those are going to be representing smoke alarms. And so this coming week, when we come to class, this building has multiple businesses inside of it, and each of those businesses has its own panel that controls the lights that go to that particular business. So each business is paying its own power bill. There's not one power bill for the entire building. Each individual business has its own power bill. It has its own panel. And so if we follow that to the basement, we can see that our beauty salon has a storage area in the basement, and all of the receptacles are labeled with a BS3, which is telling us that these receptacles, that 3, it's going to be circuit number 3 in the beauty salon panel. So each of these feeds are going to come back up to our beauty salon and into the panel for that beauty salon, so that the storage area is also on the same power grid as the rest of the beauty salon, so that they can be billed for their electricity separately from the other businesses. When we get ready to calculate how much power this building needs, we're going to count how many receptacles there are in the individual business, so that we can see what size wire we need, how much power is it going to require. We can also calculate it. We can get a minimum number by using the square footage of those rooms. Now this print doesn't have the square footage. We have another set of prints that has our square footage that we're going to look at and reference when we get ready to count our volt amperage for the room. Now we're going to do it both ways. We're going to figure the minimum based off of the square footage of how many receptacles that we have, but we're also going to count our receptacles and issue a minimum volt amperage of 180 volt amps per receptacle that we're going to use to also calculate. And the reason that we do that is because the minimum, it's a minimum. As you see in our insurance office, I'm not sure if they are planning on running a Bitcoin operation or what they've got going on here, but they have 9 quad receptacles in a room that appears to be not much larger than a 10 by 12 room. And so that it's going to require more volt amps of coverage than this room requires. And so we want to count that when we're adding those things up. And those are all things that we'll talk about in class this following week. Another symbol that we have right here is the triangle with the black line, the half black, half white. It's a specialty outlet. In this case, it's representing telephone or Ethernet. We have another symbol right here we haven't talked about yet. It is the receptacle, but it's inside of a box. It being inside the box, along with that little F to the side, is telling me that this is a floor receptacle, along with Ethernet or phone. There's going to be, somewhere in the plans, there's plans for there to be a desk in this location, and rather than run an extension cord along the ground to a wall where we can power it, we're going to power it directly from a receptacle in the floor. A few more symbols that are on here. We have this symbol is representing a fan in this case. We have a special purpose outlet here. It doesn't tell us what it is, just that it goes to the owner number 6. That would be specified somewhere exactly what that receptacle, what that special outlet is doing. Let's move on to our panel sheet. And so if we look at the beauty salon that we've been looking at earlier, we can see that each of the breakers is numbered 1, 3, 5, 7, with the odds down the left side, and pull back a little bit, the evens on the right, 2, 4, 6, 8. And so what that does for us, we have our 3 phases: phase A, phase B, and phase C, and each line of the breaker panel is a separate phase. So back all those out. 1 goes to phase A. 3 goes to phase B. 5 goes to phase C. This isn't that big of a deal when we're talking about separate breakers, but the reason that this is important is once we get down to number 15, our HVAC equipment, which is running off of 3 phases of power, those 3 in a row each are on a different phase, B, C, and A, which allows us to have one breaker that takes up 3 spots that covers all 3 phases. Something else that is important for us to do is we want to be sure that we try to balance our 3 phases. If we look here at each of our phases, it tells us exactly how many volt amps we are counting towards each of our breakers, or each of the loads that are on each of these breakers. And we want for these to be as close to even as we possibly can. So here we have 20,000 volt amps, 17,000 volt amps, and 17,000 volt amps again. It's not perfectly balanced, but it is within the range that we're looking for it to be. One last symbol that I missed earlier that I want to go back and cover. If we go back down here to our Bitcoin mining operation in the insurance office, we have a IG symbol that's beside all of these receptacles, and what that's telling us is that there is an isolated ground. In our residential class, when we talked about pulling wire through a home, every wire pulled to every receptacle, it has a black hot, a white neutral, and a copper ground. Every receptacle, every switch throughout the house has at least those 3 wires pulled to it. In a commercial environment, that's not always the case. In a commercial environment, you're always going to have a hot, you're always going to have a neutral, but your ground can actually be the conduit. The conduit can form the ground circuit for the building. But that's not always ideal for electronics. You can have noise and interference that can affect certain electronics, and so they require an isolated ground, which is a separate ground wire that has been insulated, that has a green jacket that is pulled all the way from the receptacle back to the breaker, and that is what this IG is telling us for that particular instance. I also want to take a look at the elevation plan here for just a moment. I didn't include this particular one in your packet that I handed out. It is in the packet that is online, and we can see that on the outside of the building, the electrical service coming in, and each of the separate meters with a separate disconnect that is going to each of those separate industries. That should cover most of the symbols that we're going to use on Monday or Tuesday of next week. If you would like to look over some more of the commercial symbols, you can in our on Blackboard. There is a copy of the blueprint reading manual that has all of the symbols in it. We'll be concentrating on the commercial portion of that text for this classroom. Look forward to seeing you next week.